All right, last one for today. When there's a horizon, which is that horizontal line I've done bold for you there, the angle that goes up or down is given a special name. You may have learnt it previously. Anyone know? The one that goes up is called? Elevation. Very good. Versus going down? Depression. Very good. So it's measured up from the horizontal, so down from the horizontal, and angle of elevation is up from the horizontal. Anyone know why this is true? Why is angle of depression and elevation equal to each other?
Because it's like you've got 180 degrees. Like the line at the bottom, that's 180 degrees.
Yep.
So the elevation plus the other angle over there, the one on the other side of the hypotenuse. This one here. So these 180.
Oh, yes. So they're supplementary.
Yeah.
Yep.
And then like this is a straight line, so you've got like I think there was a rule that was like this is equal to this and this is equal to this. And, yeah.
Close.
Yeah.
You're on the right track. Now, let me just explain it. What I'm just going to elaborate on what Raf just said there. Thanks, team. Year 9s. Shh. Thank you. What Raf just said, there's actually two ways to prove it, but it does mean you have to know your angle of parallel properties. Yes, it is correct that whatever this angle is, let's call it theta, the angle that, because this is a straight line, that must add up to 180, so we call that supplementary. But what was interesting is that these two angles in a parallel property, what is it called? I'll draw it again. You learned it back in year 8 or mainstream year 8. You have this outside angle, which is obtuse. So that's my obtuse angle. And then you've got an acute angle up here. What are these two angles called? Starting with C. Oh, wow, we all forgot. It's co-interior. And if it's inside the parallel line. So interior, and they're both on the same side. So it's co-interior. What's special about co-interior? They must add up to 180. They're supplementary. Or an easier way is that angle, this acute angle, they are equal due to, starting with A, which property? No. These two parallel lines, and then you've got a transversal line that cuts through. This angle and this angle, what's the name for that again? Oh, wow. We forgot all our 4 properties. So, one's called corresponding. 2 is called co-interior. Yes, alternate angles. And 4 is vertically opposite. I taught it to my year 8s, just like term 1.
No, you didn't.
I did.
Oh, did you?
Oh, I wasn't there for you for term 1, but this term 1, 2025.
Yeah, I think you still taught us.
So vertically opposite is when they're directly opposite to one another. Corresponding is if they're on the same side of the transversal line. One's on the top, one's on the top, one's on the bottom, one's on the bottom. Alternate is when they're doing exactly the same thing. They're either interior or they're exterior. But that's why we know these two angles are the same. Okay? Yeah.
What does the second one say?
Go interior.
Oh, sorry, I didn't. I just assumed you all learnt this property already. There's only 4.
We did. It's hard to remember.
You do need to know this.
Yeah, because unlike everything else, there's no like pattern to remember it.
Oh,
You just have to
this
remember
one you have to know. It's a prerequisite for when you're doing geometry problems. So when you're doing methods, this is a prerequisite that you're meant to just know, like your times tables. So you need to know all 4 of them. Yeah. Maybe I'll spare a session towards when I have some free time. I'll spare a session to teach you how to remember this. All right, team. So let's do one example. Example 1, bird is hovering at an altitude of 100 meters. I've got a diagram for you there. The angle of elevation from the observation point, which clearly is here. This is the observation point. Observation. Angle of elevation, so it has to go up from the horizontal line. So it's 55 degrees. Find the horizontal distance of the bird from the observation point. Horizontal distance means from left to right. So that means I am looking for this distance here. Based on what I've got, I can see I've got this side. The 100 meters represent which side? Hypotenuse, opposite, or adjacent? Oh, for opposite. The side that I'm trying to find is called the... So I got O and A. Function I should be using? Tan. So tan of 55 degrees should equal to opposite, which is 100, divided by A, which is the question mark. Well, I'll call it A for adjacent. This is what you did in exercise 6A. How do we solve for A? What do we do? Very good. Multiply both sides by A because that's the opposite of divide. So times them. A divided by A cancels out. You end up with 100 is equal to A times tan of 55. But I don't want A times tan 55. I just want A. So how do I get rid of times tan 55? Divide. Very good. So here, opposite of times is divide. Divide by tan 55 on both sides. Tan 55 divided by tan 55 is 1. Anything divided itself is 1. So therefore, A must equal to 100 divided by tan of 55. Use your calculator. Make sure it's in degree mode. Here we go. Let's check it out. 100 divided by tan of 55 is set to the nearest centimeter. Is it in meters? Well, I guess you have to change it to meters and centimeters then. All right, so currently it's 70.02 meters. Currently it's... Yes, very good. So that's in meters. Because they asked to the nearest centimeter, I have to times it by 100. Times by 100 in the calculator, I get 7,002.07. So the nearest centimeter must be? Very good. So I'm just going to write it again. It was 70.0207 meters, but that's equivalent to 7,002.07 centimeters. Therefore, rounding it gives me 7,002 centimeters, nearest centimeter.
I got 7,002.08 centimeters.
Oh, big question. Big question.
But they said to the nearest centimeter, yeah?
You can round up for the last
That means I'll round it up.
No, you see, you look at the next digit. Because nearest centimeter is 7,002, and then you look at the next digit,
But the
which
next digit for me is 8.
yeah, even if this is 8, the point is the 0.
I'm just worried about making the wrong calculation, the wrong answer.
Oh.
Not that it's going to influence the end.
Oh, no. So you're right. It would be 8, but it must mean your calculator is, mine's on float 8. So in your settings, you might have float 6 or something. So it's 1, 2, 3, 4, 5, 6. This is why at year 11 and 12 methods, we encourage 8 and above. Because then you get more decimals. So it's your settings. If you want to change it, go to document. Go to 7. So document, settings. And you change the float. Change it to from 6 to 8 or 8 and above. You get more decimals.
What's fixed?
Document.
Fixed is like, wait, where is it? Fixed on the bottom, yeah?
Wait, where'd you go with the settings?
So it just means that it rounds to 8 digits instead of rounding to 6.
Yeah, but I thought that's what floats means as well.
Restore factory default.
Yeah, that's what I found.
I don't know, actually.
Then I'll reset it.
I need to play around with it, actually, to find out.
Wait, what do we do after settings?
Yep, go to document,
So what
Settings?
calculation mode?
document settings.
Like, so there's a calculation mode. What is... Oh,
I keep it exact because I work with year 11 methods. Most students have it on auto.
yeah.
In general maths, you do approximate. And it just means that when you type in the answer, it automatically changes to either exact value or decimal value. And in methods, we keep it in exact value. is what we prefer.
So how do we get it to go to decimal value?
Then on the calculator for us, we can do Control Enter.
Yeah, yeah.
It does an approximate answer.
Yeah, but it still sometimes annoys me that I press the control as well. So how do I change it so it automatically goes to
Oh, then you change it to approximate.
approximate? Okay.
Yeah, approximate will always make it a decimal regardless. The reason why I don't like that for methods is because it's hard to change from decimals to exact value. That's why. All right, team. And let's do one last example, and that's it for today. Here we go. Two vertical poles, 32 meters apart, are 62 meters and 72 meters high. So what I'm saying is I've got a pole, one is 62 meters, the other one is 79, and they are 32 meters apart. So they must be apart by 32. What are we doing here? Find the angle of depression from the top of the taller pole. So from the top of the taller pole to the top of the shorter pole. So this is the line that I'm looking at. We are looking for the angle of depression. So that means from the top of the taller pole, we're looking at this angle here. That's the angle we're looking for. That's what they mean. Correct to 2 decimal places. So what we can see is if I did a horizontal line over here as well, so it's parallel, we know that the angle of depression is equivalent to the angle of elevation, alternate angles. So that's why I know this angle here is also theta. So from that point, we can now solve because we've got a right angle triangle. We know that this length here is 32. How do I find the height? Very good. 79 minus 62. And what's 79 minus 62? 17. Very good. So now if you write out your triangle again, I'm just going to draw it out on the side so you can see. 17. Angle. 32. Name the side. 17 and 32 is opposite and adjacent. So which function do we use? Tan. So tan of an angle has to equal to 17 divided by 32. On your calculator, figure out what tan inverse of 17 on 32 is. Correct to 2 decimal places. Round this to 2 decimal places, what do you get?
27.9.
Very good. 2 decimal places, 27.98. Don't forget your units. Meters. That's 6B, 6C. So finding angles and then angle of depression and angle of elevation.
I thought my next sheets are always so chaotic.
That's right. We're working for the angles, so it should be degrees, not meters.